in behavior on Friday and what the ends do, or on Thursday. Now let's talk about some more analysis. So I'm going to do, and I'm just going to pull that, actually the one on number 2, something similar to that. Something like this. Say that again. Don't start this today.
I just wanted to see.
Yes.
And then the odds.
Let's see how well you do remember it. If I drew this, if you just looked at this, do you think that this would have an even degree or an odd degree? Why? But what about it says that? They're both going in the same direction, right? And when they're both going in the same direction, that tells me it's an even degreed polynomial. So whether they're up or down, as long as they're going the same way, that tells me it's even. Now, because they're going down, that tells me that my leading coefficient is what? Positive or negative? Negative, that's right. If they both went up, it'd be positive. If they both go down, it'd be negative. Okay? All right, now let's talk about some important points here on this graph. Let's look at, and these aren't exact, but I'm going to look at these points. What do you notice about the 2 points that I circled? They're high points on the graph. Do you agree? So I call them, you're exactly right, I call them maximums, but there's 2 different kinds of maximums that are happening here, okay? This one is a maximum, but it's not the highest the graph ever goes. Does everybody see that? Even though it's a high point, it's not the highest point. So I call this a relative maximum. The other one is the maximum because it never goes higher than that, right? Do you see the difference? So I call this an absolute maximum. See the difference in the 2? Now, if I use that same thought process, then looking down here, what do you think that would be? It's a low, right? But is it the lowest? It's a minimum. Is it
relative minimum?
It's a relative. Why is it relative?
Because they go on forever in negative infinity.
That's right. This is a relative because even though it's a low point on the graph right here, these arrows are indicating that I go down forever. So it wouldn't be the absolute minimum. It's just a relative minimum. Does that make sense? This is REL. Sorry, I was just abbreviating. I see some of y'all staring at it like, what in the world are you writing? But you know. All right. Now, algebraically, what happens at these maxes and mins? Here's what's happening, and this is where we're going to get into this decreasing and increasing that we talked about before. You read a graph the same way you read a book, left to right. Okay, so as I move from the left to the right, notice what the graph is doing. It's going up. Do you agree? As I start. Up, up, up as I move left to right until I get to that point right there. So from all the way this way up until I hit that point, I'm what we call increasing. So increasing just means as you move left to right, the graph is going up. Now notice the point that I stopped going up. The point I stopped going up is actually that maximum value. This is where that happens. And what happens once I pass there? What's it doing? Left to right. It's decreasing. That's exactly right. It's what we call decreasing. Okay, so decreasing is exactly the opposite. It's as I move from left to right, the graph actually goes down. What's this next little interval? I'm sorry.
Oh.
Which would be plug-in. Move out. Increasing. This is an increasing interval. That's exactly right. And how about this last piece? Decreasing. Okay. It's a very easy concept. We're fixing to crank it up just a little bit and start naming these intervals. But for right now, I just want you to be able to identify them. Do you see how we identify maxes, mins, increasing, decreasing? Okay. Notice maxes and mins always occur when we change from increasing to decreasing or vice versa. Sometimes we call maximums and minimums turning points for this reason, okay? Because they'll stop going up and start going down or vice versa. All right, y'all ready to make it happen? Logan, get up. What the heck? Take out your calculator and graph this one. You don't know how to do that?
Oh, that does the funny little. Ooh. There's one that
All right, so I'm going to do y equals. Hit the y equals button here. And I'm going to type negative. Use the x button beside the alpha. X raised to the third. You got what? And then I'm going to do plus 3. I'm going to hit X again and then the squared button. Make sure as you look that none of these plots here are highlighted in black. See how mine are not highlighted? If they look like this, you need to go up, hit enter on them, and come back down. Because it's a stat plot and it'll mess your graph up. Yeah. The button right below clear. It probably took you up to an exponent. Yeah, so once you get up to the exponent, hit the button to the right to come down from it. Well, you had to put a 3 there. That's x to the third. Your calculator's just a little bit fancier than mine. All right. Everybody's plots off. Equation entered.
Yep.
Hit zoom. Right here in the middle. Zoom. 6 for a standard window. That's going to give me a 10 by 10 window.
Hey, I knew it was going to do that. Hey.
Oh. Zoom 6. Well, we're fixing to get into a whole lot in just a second. So y'all stay with me because there are always questions on what we're fixing to do. All right. Tell me what you see.
A line.
Tell me about the end behavior first.
As x approaches infinity,
As x goes to infinity, f of x approaches, what did you say? Negative infinity.
X approaches negative infinity, f of x approaches infinity.
Does your 4-square chart support that? If you look in the square that says negative leading coefficient, odd degree, is this the end behavior?
I don't know. Yeah.
Yes. As it should. Everybody okay so far? All right. I'm going to sketch this graph. Do a little labeling here. Looks like this, something like that. All right. We've got the end behavior. Do you see any maximums? One maximum. Is it relative or is it absolute? Why is it relative and not? There you go. All right. What else do you see? A relative minimum. If I approach my relative minimum, am I increasing or decreasing? Job. As I go from my minimum to my maximum, am I increasing or decreasing? And as I go from my relative max to the end, am I increasing or decreasing? Anybody confused? All right, let's get to a little bit more. By the way, what's the domain on this one?
Infinity.
How about the range? Same thing. It goes up forever, down forever, which tells me it's negative infinity to infinity. Everybody okay? Here's what I have to do now. Not only do I have to label them on a graph, but I need to know the coordinates of each point. And then I'm going to tell what these intervals are that are increasing and decreasing. Okay? So right now you're at a 1, 2, 3, 4, 5, 6, 7-point analysis with all this. We'll get to where we're about a 15-point analysis, I think, is what we'll end up with. Yeah. Lots of analysis to do. So don't. All right, Hank, now you're going to ask me 100 questions. You got this? All right, let's calculate it. First thing I'm going to focus on is this point right here. So take out your calculator, back out. I am going to hit second trace. If you are not good at following directions, you need to write this down, okay? If you need to go back and look or anything of sort. Second trace. What is it I'm trying to find? A minimum. So select minimum. That's option number 3. And hit enter. Have we? All right, so I need to go left of the minimum. See my spider blinking? I need to go left of the minimum. Generally, 3 clicks is good to clear it. Hit enter. And now it says right bound, so I'm going to go to the right of that minimum. And I'm going to hit enter. Did we do it with the parabolas? Oh, good. Then I won't have to spend as much time. Guess Just make sure you've gone past the minimum as you go right. Generally, you can kind of put the little spider on the minimum and then hit right 3 times and you're good. But just notice how I hit right enough to where it was past where I know that minimum is. And then you have to hit guess that one last time so that you can calculate that point. Just hit enter. Now, anytime you see this, and this is very important, what does this mean? Which means what? I thought we talked about this, but maybe not. Round that to 0. That's 0. Anytime you see E with a negative number here, like this, your calculator has problems with the pixelation and stuff, that's 0. Okay? So, 0, 0. That's exactly right. That's what the minimum. See, I've got both of these, E to the negative 7, E to the negative 12. I'm going to call that 0, 0. Okay? If you've got a newer calculator, it probably went ahead and gave you 0, 0. Okay? So what I'm going to do is come over here and say that this minimum is at 0, 0. Okay? Very, very important. Okay? We have a relative minimum at 0, 0. Everybody okay? All right. Calculate the maximum, see what you get.
Oh, that really is like 3, 4.
Is it?
3, 4 and a half.
Don't guess, be exact. 2, 4.
I don't know. I don't have my calculator out.
This point is 2, 4. That means I have a relative max at 2, 4. Everybody okay? Now, here's what else I have to do. I have to describe these increasing and decreasing intervals. Okay, so let me show you how we're going to do that. Logan, stop. Stretch. When you get your legs up. Yes, we don't want to see all that. All right, increasing intervals. Where is the point where my function is increasing? And here's what I'm going to tell you. We use the x values to describe. All right. Increasing intervals. You said from the minimum to the maximum. So describe that using the x values from what to what?
0 to 2.
From 0 to 2. Those are my increasing intervals. That's not bad, right? If you've labeled it and you see it, it's not bad. How about the decreasing intervals? Keep it as the x. We always use x to describe.
Negative infinity to 0.
There we go. Remember x. That's exactly right. We're going to do this side, which is negative infinity. Whoa. Negative infinity until I get to 0 and I stop. And then I join that with a u and I go from 2 to infinity.
When you use brackets, because you find the f of x on this one.
No, because at that point it's stopped. It's not increasing or decreasing. It's changed direction. Questions? Y'all took to that way better than I thought. Let's do one full analysis together and then we will. How about that? Let's do, no. You don't have very many of them. Here's what your homework looks like tonight.
What is supposed to be a hard lesson?
Well, some people have not been paying attention the whole time.
What?
And I'm going to hate it when I have to hurt their feelings when they ask me how to do it.
Yo, sorry.
All right, negative x to the fourth. I'm going to type this in exactly the way. Oh, sorry. Think so?
Yeah. All right. So then I'm going to do all of it. All right. Well, can I just try it first and then?
Yeah, go ahead. Yeah.
Lunch today. Does anyone know? No. Oh no! I'm good. Let him cook. Who let him cook? We burn it now. Oh, I think I done do crooked. Look like this? What happened? Let me see. Let me see, BJ. Yeah, it's supposed to look like that. You're lying. I mean, I haven't done it, but I know it goes in the same direction and it's negative, so yeah, it looks like that. It looks about right. You know that FW ball. Yeah.
All right, y'all got it?
I think so. Can you at least show me? I just want to see how my graph looks.
All right, I got negative x to the fourth plus 4x squared minus 3x minus 2. I'm going to do a zoom 6 on it.
Oh, hooray!
If you start getting confused on is it a max or a min or whatever, look to see, do I ever change directions? Do I stop increasing and start decreasing or vice versa? And that'll tell you if it's a max or a min there. All right, so let's do the analysis on this one. Let's see what happens. I'm going to go ahead and sketch it because you will have to graph it for your homework. You'll have to do a graph. So I'm going to come here and I'll just go ahead and put the graph. The graph doesn't have to be exact because for these, we are strictly using our calculator. Looks like it does something like this. I'm going to come back to the domain and range. I'm going to do that last. Let's do in behavior. You want to do in behavior first? All right, in behavior.
That'll boy.
Okay. Perfect. In behavior. Tell me what you notice on here. Do I have any maximums? Yes, I've got 2.
Actually, one absolute and one relative.
Now, on your sheet, it all says relative. That's because, here's where you have to be careful. Every absolute is also a relative, but every relative is not an absolute. It's kind of like the square and rectangle thing, right? Because by definition, relative says it's a high or a low in a certain area. Absolute says it's a high or a low for the whole graph. So this is still a high or low, so I can still call it a relative, even though it's an absolute also, if that makes sense. So you'll list all your maxes and mins where it says, even though it says relative. But I want you on your graph to mark if they're absolute or not. Does that make sense? Okay. All right, I need the coordinates of these maxes and mins.
I forgot how to do that. You do the spider. Spider.
Second trace.
Spider. Terry.
Logan, can you please? No.
Not as much as Auntie, but close enough.
Okay, let's see. Which one? You did this tall one first? Okay. Hold on, and I'll go back to that one. Let me calculate this one. Negative 1.57. Yeah. Yes, please. Thank you. I did. I'm around at 2 places. That's what I got for one of mine. I did the left one first.
Yeah, I'll just fill it up.
Give it to Logan.
I'll just come help.
All right. What about the other maximum? You still have to calculate. Left, right, enter. I got 1.16 negative 1.91. So what y'all got? Yes.
I got negative, no, I got 1.7.
Hit enter whenever it says guess.
Yeah, I got that.
There's no way.
I'm being so serious. My other one's closer.
Did everybody else see what I got? Oh, you know what? You didn't scroll far enough over.
How far should I scroll?
Make sure you clear the highest point.
Oh, so clear the high point.
Yeah.
Okay.
Right. All right, there's my 2 maximums. Calculate the minimum, see what you get. Thank you, Logan. How do you know? How do you know?
Oh, that's on your homework sheet?
What do you mean by cash?
It's the same one we had last week, right? I don't even remember if I got that.
Mm-hmm. When you hit the second button, it calls up all the commands that are in the color of the second button. Yep. Yep. Logan, stop. Look, this seems easy now. You put it all together and it gets complicated. All right, I have my maximums. I have my minimum. The next quiz you take, which is going to be soon, will be all analysis. You'll have to be able to do this on your own. You didn't go far enough over. That's got to be what it is. Logan, go help BJ on his minimum.
I go from.
What do you mean? Yeah, oh yeah. I post them all. Stop. All right, Logan's coming to help you.
Yeah, what's up, homie?
All right. As he finishes that one, let me go ahead and label these increasing, decreasing, domain, and range so those of you who've got it can go ahead and get started on the work. I need my increasing intervals. So where on my graph am I increasing? So I've got from here to here, this is increasing. Is that the only place I'm increasing on my graph? No, there you go. That's exactly right. Here I'm increasing as well. So how are we going to describe these two intervals? Always start furthest left. 2. I just did because it was a 0, and I didn't want anybody to be confused. So I'm going to go negative infinity, and then I'm going to stop at this absolute maximum here. What is that x coordinate? That's this one. So negative 1.57. Then I'm going to pick up at this minimum, which is 0.409. And I'm going to go until I hit that second maximum, which is 1.16. Those are all of my increasing intervals. Yep. How many decreasing intervals do you see? Okay. The two that are left are decreasing. So now let's describe them. And it may help you to put the coordinates of each of these points on here so that you can see those x values. But decreasing, I'll come up here. So decreasing, I'm going to go from the x value of this first maximum, so negative 1.57, until what? You tell me. That's right. 0.409. Then I'm going to pick up at this maximum, which is 1.16, and I'm going to go to infinity. Because this way is positive infinity. You're looking at the x, not the y. All right. Domain? All right, I would like for everyone to put your phones up a minute. Let me tell you why this is insulting. Those of you who are on your phones are the very ones who are going to ask me, you've been on your phones, asleep, whatever, not participating. What's going to happen is you don't know how to do it, and then you think that I'm supposed to take more time to reteach you what I've already taught. You be responsible for you. Please don't make me be that teacher that has to start taking phones and calling mamas because you're not doing what you're supposed to do. Unless you 100% could make an A on this right now, put your distractions away and focus. Now, what is the domain of this function? Yes, what is the range?
Negative infinity, and then what's the top? 6.1.
Where are you getting that?
Maximus.
That's exactly right. This is the highest point. That highest y is 6.49, and it needs a bracket because it is an actual point on the graph. All right, you have